lecture we will see electric potential energy and electric potential. So what do you mean by electric potential energy or electrostatic potential energy? So electrostatic potential energy is the work done against electrostatic forces to achieve certain configuration of charges in a given system. The exact meaning of certain configuration of charges in a given system we will define now. Okay. Here, therefore, du is equal to F dot dr. So this is definition. By using definition, we can write here the formula of electric potential energy. So electric potential energy, here we have given notation du, F is force and dr is displacement. Here, let us see expression for electric potential energy. This is diagrammatic representation in order to obtain electric potential energy. Now, consider an electric field due to a positive charge Q placed at a point O. So this is the electric field of a point charge plus Q, and this field is extended up to a point B, that is up to R2. Now let a charge plus Q0 brought from A to B at the respective distances of R1 and R2 from point O. The work done against electrostatic force in moving a charge plus Q0 through a displacement dr is given by du is equal to minus F dot dr. This is equation number 1. Here, this negative sign indicates that the displacement dr and the force are in opposite direction. The change in potential energy delta U is obtained by integrating equation number 1. So we can write integration of equation 1, and this integration is equal to delta U is equal to integration running from R1 to R2 minus F dot dr. Okay. Here integration running from R1 to R2 minus F dot dr. So here we have applied work here. So we have done work is done against electrostatic force in moving a charge plus Q0 from a point A to point B. So A is situated at a distance R1 from positive charge plus Q, and B point is situated at a distance R2 from plus Q. The electrostatic force between plus Q and plus Q0, if it is separated by distance R, is given by F is equal to 1 upon 4 pi epsilon 0 Q0 upon R square into R cap. Okay. Now by using equation 2 and equation 3, so this is equation number 3 and this is equation number 2. So we can put this value of F bar in this equation number 2. We get delta U is equal to integration running from R1 to R2. So R1 is initial limit, R2 is final limit, minus 1 upon 4 pi epsilon 0 Q0 upon R square. So this is value of F into dr. Now therefore delta U is equal to minus Q0 upon R square, Q0 upon 4 pi epsilon 0. Outside integration, only variable quantity is distance or displacement. So we can write integration R1 to R2 1 upon R square dot dr, equation number 4. Okay. Now let us solve this integration of R1 to R2 1 upon R square dr. We can solve this equation by using our mathematical formula, that integration R1 to R2 1 upon R square dr. So integration of 1 upon R square is minus 1 upon R. So integration running from limit running from R1 to R2 is equal to, first of all negative sign is outside this bracket. Here put value of R is R2, then R1. So 1 upon R2 minus 1 upon R1. So this is answer of what? Integration of R1 to R2 running from R1 to R2 1 upon R square into dr. Okay, dot dr. So put this value in equation 4. So integration. So we get equation delta U is equal to capital Q0 upon 4 pi epsilon 0 bracket 1 upon R2 minus 1 upon R1, equation 5. Now this change in potential energy is called as electrostatic potential energy W. Therefore W is equal to capital q0 upon 4 pi epsilon 0 in bracket 1 upon r2 minus 1 upon r1. So this W is called as electrostatic potential. If r2 is equal to r and r1 is equal to infinity, if the positive charge q0 is placed at infinity, then we can write r1 is equal to infinity and r2 can be written as r. So put this value in equation number 6. So equation number 6 is given here. So after putting this value, we get here, if we put this value, we get r2 is equal to 1 upon r. So 1 upon r is here and minus 1 upon r1. r1 is equal to infinity. Here 1 upon infinity is equal to 0. Therefore W is equal to 1 upon 4 pi epsilon 0 q0 upon r. This is equation number 7. Now this equation number 7, remember that because this equation is useful while obtain expression for electric potential. In next slide we will see unit of electrostatic potential energy. As we know that the unit of energy is joule. So here for electrostatic potential energy, its unit is also joule. But joule is big unit for in case of electrostatic potential energy. So for our convenience, we can use electron volt, and 1 electron volt is equal to 1.6 into 10 raised to minus 90 joule. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Here we can define 1 joule. So 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. So here definition of 1 joule, I repeat again, 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. In next article, here we will define here electric potential. So what is difference between electric potential and electric potential energy? Slight difference is there. Only slight difference is there here. Electric potential difference, the electric potential is defined as the amount of work is required in bringing unit positive charge q0 from infinity to a point in a field against the direction of electric field. If suppose if you consider charge q and its electric field, and if we placed the charge is outside the field of positive charge q, then that charge can be considered as is at a infinity. Then amount of work is required in bringing unit positive charge from infinity to a point in a field against direction of electric field. Here it is denoted by letter V. Its SI unit is volt and formula can be written as V is equal to W upon Q0. V is equal to W upon Q0. Expression for electric potential due to a point charge here. Now consider an electric field due to a plus Q charge placed at a point O. Okay. Now let Q0 be the test charge, is at a point M situated at a distance x from O. Now this M is considered as out of field. So any charge which is out of field of plus Q is considered as a infinity. The electrostatic force between plus Q and plus Q0, if it is separated by distance x, is given by F is equal to 1 upon 4 pi epsilon 0 Q0 upon x square. This is equation number 1. Work done against electrostatic force in moving a charge plus q0 through a displacement dx from m to n is dw is equal to minus f dx. dw is equal to minus f dx. In previous case, for electrostatic potential energy, we have written dw is equal to, or delta d is equal to minus f bar into dr. So in that case, here the displacement is considered as a dr, and here for displacement is considered as dx. Now putting a value of f from equation 1, we get dw is equal to minus 1 upon 4 pi epsilon 0 q0 upon x square into ds. Question number 2. Here f is given. We have put the value of f in equation of dw. Now after integration, from infinity to r. So here this equation A means, so distance of A is r, therefore W is equal to integration of dW is equal to, here we know that the point is at infinity. If the charge is placed at infinity, so if final initial limit is infinity, so our final limit is r, minus 1 upon 4 pi epsilon 0 q0 upon x square into dx. Here where the variable quantity is only x square, x and dx, so here we can write, therefore W is equal to minus q0 upon 4 pi epsilon 0 integration infinity to r 1 upon x square into dx, equation number 3. Now integration running from infinity to r 1 upon x square dx, so 1 upon x square, integration of 1 upon x square is minus 1 upon x, minus sign is here, initial final limit is r, so we have put here r, then initial limit is infinity, after putting 1 upon infinity, so 1 upon infinity is 0, we get minus 1 upon r. So integration, so value answer of this integration is minus 1 upon r. Put this value in equation 3. Let us see again, I repeat again, here if after putting this value of W in this equation, okay, W here 1 upon 4 pi epsilon 0 as it is, q upon r as it is, and this q0 get cancelled, putting we get this equation. So this expression, that is equation number 5, is electrostatic potential, electric potential or electrostatic potential. Next article we will see relation between electric field and electric potential. Now figure is same as that of electric potential. Consider electric field due to a point plus q charge plus q placed at a point O. Let q0 be the test charge at a point M situated at a distance x from O. Now the electrostatic force due to electric field is given by F is equal to q0 E. This is definition of electric field, F is equal to q0 E, equation number 1. Now work done against electrostatic force in moving a charge plus q0 through a displacement dx from M to N is given by dW is equal to minus F dx. Now put the value of F from equation 1, we get dW is equal to minus q0 E dx, here q0 E dx. Now take q0 here, dW upon q0 is equal to minus E dx. Okay, dW is equal to q0 upon minus E. Now electric potential energy, electric potential is given by dV is equal to dW upon q0. Okay, now dW upon q0 is what? Minus E dx. Therefore E is equal to minus dV upon dx, where E is electric field and V is electric potential. So this is the relation between electric field and electric potential, where dV upon dx is called as potential gradient. In this article, here we have seen two concepts. First one is electric potential energy and electric potential and relation between electric potential and electric field.